on this computer. So I want to real quick write up the formulas just one more time from the stuff we learned the last two times last week. So here goes. Let's do that. So for simple interest, we had this I equals PRT thing. That's how we directly calculated interest. Oh, Jennifer, I have no idea. For the midterm, I think it was 85 points. I do have an idea. That was a total lie. I think it was 85 total. Yeah. I totally forgot to respond to your email. Sorry. I am going to go. I think that the midterm closes tonight. So after tonight, so tomorrow, I'm going to go in and grade the exams, and you'll get a chance to see. Oh, that's interesting. It shows you a partial grade already. Well, that has to be frustrating. And once it's graded, I'll make sure you can look at what you got right and wrong. And so, maybe there's some work you did that's worth looking at for partial credit. That kind of thing. So I wouldn't stress too much about what you see there already. Because it's pretty unforgiving in terms of grading. You have to have it exactly right. So if you were off by a decimal place, I probably will give you the points, full credit, or take off a half point or something, or maybe 1/2 point for the entire exam if you didn't round things correctly. Okay, so for simple interest, this was how we calculated interest directly. For compound interest, we had to know the future value first. So then for the future value for simple interest, these three things are all the same thing. For compound interest, we had two that were essentially the same. There was this one, which was annual. Not annually, yeah, annually. In other words, n equals 1. And then the more general term, which is for any n, compounded n times per year. And then we had a third one, which was different than these two. These two are related, although they are both slightly different. And that was A equals P raised to the RT, and this was continuously. Right, so those were the three things for future value. And then we had a separate kind of little side formula here, which was the effective interest formula that was 1 plus R over N raised to the N power minus 1. And this little formula, remember, it compared, it was a way to compare different compounded interest rates to determine which was better based on the context. Do we want a lower interest rate for borrowing? Do we want a higher interest rate for savings or investing? So this is the set of formulas you need to be comfortable using, and you need to know what each of the letters represents and how to find them in a problem for section 3.1 and 3.2. And we're now going to add like 2 more that use these same letterings. P is the initial value, the initial investment or initial borrowing. R is a percent, T is time in years, N is number of compounds per year. Any questions on these? Anything blowing you away? All right, let's do it. So today we're going to buy a car. And then look at some crazy stuff with credit cards. So what's happening here is we're going to look at payments for installment loans. And then we're going to look at the true cost of a loan by computing APR, which is the annual percentage rate, which it's related to this formula, compounded once per year. And then we're just going to look at evaluating, the cost of buying things. I like this quote: before borrowing money from a friend, it's best to decide which you need most. Yeah, you shouldn't borrow money from friends and family. That doesn't tend to end well, right? Or you shouldn't loan money to friends and family. Just assume you're never going to get the money back, right? Just go through the bank system if you can. So what we need to understand is, what is an installment loan? So installment loans is you buy an item and you pay for it making periodic partial payments or installments. And most often these periodic payments are done monthly. So your student loans once you graduate and they go into repayment period, right now they're going to be in deferment while you're in school, they're going to calculate the total interest you're going to owe on it by the end, and then divide that by the number of payments, and you're going to make those payments over time. So this is like what we're doing here is calculating how much extra it's going to cost us because we didn't save up the money to buy something right offhand. So here's some of the language we need to work with, and here's some formulas, and I'm going to write these in letter notation. First, we've got the idea of a fixed installment loan. That means you make equal payments over the lifetime of the loan. So you're given a term, is most often what it's called, which is the length, how long it's the loan shark or the loan person is going to give you to pay it off. And then they're going to calculate the total cost and divide it by that length. Most often there is some sort of down payment. So this is cash you bring to buying something. So you give some money to reduce the amount you're borrowing. That's the down payment. And lots of times you want that, especially when buying a house. If you can put 20% down on the house, it saves you a lot of money. Okay, so then we get this idea of the amount financed. This is how much you borrow. If we think about the letters we've used before, the amount financed is going to be the P. And so the principal, that's the amount we borrow. And then that principal is just going to be calculated the price minus the down payment. We don't really have special symbols for those. Remember, this is cash you have. This is money in your bank account. And then this is the item we're trying to buy. So the installment price is the sum of all the monthly payments, sum of all the payments plus the down payment. That's how much you pay. So I like to change this total installment price to total cost, or just cost. So how much money left your bank account is the idea here. And we're going to discover that most often this sum of all payments is the monthly payments, which we're going to use the letter M, times number of payments here. We often use the letter N here, plus the down payment. So the finance charge, this is kind of like the interest. So this is the extra cost. This is how much you paid to borrow money. We'll leave it as finance charge. I don't want to use, we could use I, but what this is it's the installment price. So, well, we could do it this way. It's just the principal. Let me try again. It's the total cost. All right. So it's total cost that we calculated here minus the price. There's another way to calculate it, and I'll show you that in a second. So these three formulas we're going to use throughout this. And you might find that some of these are just kind of common sense is not the right word, but they're pretty straightforward in terms of what's happening. If you're thinking about the exchange of money, how much has left your pocket, how much extra is being charged to you because you don't have the money, then these are kind of natural. So let's start with a problem. We're going to buy a car that costs $12,260. This is the price, right? That's the sticker price. That's the negotiated price. This down payment is the cash you have. Should we say in hand, on hand? I don't know which one it is. Here's the monthly payment. So we're going to learn how to calculate this in a second. For now, we're just going to get comfortable with finance charge and the rest. So this is really the M. And then the term of the loan, 48 months. So we have 48 months to pay that off. If you're like, wait a minute, how much is 48 months? How long is that? Take 48 and divide it by 12, and you get that's 4 years. For whatever reason, car loans are always given in lengths of months, and mortgages are always given in lengths of years. I don't know why. Okay, so what was the amount financed? Well, if you look back on the previous page, the amount financed is the price of the item minus the down payment. Should we just call that F? No, we call that P. So the principal we're borrowing from a bank or something is the price of this car minus the cash we paid, so that we don't have to borrow as much. So that happens to be $9,260. This is how much we need to borrow from the bank in order to drive this car off the lot. Okay, so then the next question says, well, what's the total amount of all monthly payments? In other words, we've initiated this loan. We're told we have to pay $231.50 for the next 48 months. How much do we pay? Well, that's just $231.50 times 48. Y'all with me on this? If anyone out there's bought a car, you know exactly what's going on here. Right? Like you did this, you're in the midst of it, right? I have a car payment right now, and I would love to be done with it. Now notice, this is how much we borrowed. This is how much we're going to pay. So because we didn't have $9,260 on hand, we have to pay $11,112 over these 48 months. So there's a significant extra amount of money we're having to pay, which is what question 3 says. What's the total? Well, what's the total installment price? Meaning, how much did we spend? Well, that's this $11,000 plus the $3,000 we paid for the car. So I like to call that total cost. Total out-of-pocket cost. Here's our loan payment. We paid this over 48 months, right? And then we're adding to that the $3,000 we saved up over who knows how long. This was an immediate payment, and we ended up paying $14,112 for a car that's worth $12,260. Roughly an extra $2,000, almost $2,000. We'll just say this was the immediate payment. So how much extra did we pay? Well, let's find it. Finance charge, FC, that's equal to the $14,112 that we paid for this car minus the actual price of the car. What's even more depressing, if you think about what's going on here, if this was a brand new car, as soon as you drove it off the lot, it loses value. So maybe it was valued at $12,000 when you first purchased it, but then now that we've started making payments, it's worth even less. So $1,852. We paid this much extra. This is the extra cost, or cost to borrow the $9,260. We could divide that by 48 and see that That was $38.58 per month, which doesn't seem too terrible, right? But what if we'd had the 12,260 up front, we would have saved $1,852. That's a lot of Lego right there. I don't know what you think, but that's a lot of Lego. Like 2 sets, maybe, actually, 2 of those big ones. Okay, how do you feel about all this? Does this make sense? Anyone have any questions? Okay. So why don't you try this one? Find the amount financed, find the total installment price, and find the finance charged based on this problem. Let me give you 5 minutes to attempt it, and then you shout out. Actually, I'll make it so you can write on the screen. I think. Can you all write on the screen like I'm doing? Yeah, there's gotta be a way to, take. Oh, I know what we have to do. We have to do it on a whiteboard. Okay. You all solve the problem, and I'm going to find a way to make it so you can write your answers on the board. Oops. Now, can you write on the white? Can you write on here? Hmm. No, I'm sure you all are fine. I'm sure it's me. Oh, here we go. Open and collaborate. There we go. Now you all can write on it. I like that you got that monthly is 270. But we already know that. There we go. Yes. Okay. Go nuts, y'all. I'll give you 5 minutes. Set a timer for 5 minutes. Oh, sorry, Latoya. You're right. My bad. Okay, I was muted. All right. So let's double check what's happening. We've got 8,200 minus 1,000, which means it's $7,200. Yes, I do agree that this here, this should really be 36. So let's just do that. And let's say 36.
Yeah, that's my bad. The total is right. I'm
Oh,
going off my reference.
no worries.
Oh my God. Yeah. I knew that. Even when I wrote down it was 36 on my paper.
Love it. Hey, plus you're using a mouse, right, to try to write, which is awful.
Yeah.
Love it. Yes. So this is the total we're paying beyond the for the thing. Here's the total cost, 10,000. The finance charge. So how much did we borrow? How much extra did we have to pay? Yikes. Right? That's a lot of money, in my opinion. But so here's the thing with all of these. With cars, you got to have a car to get to work, right? So if you don't have the cash to plunk down right away, but you need the car to get to work, you're stuck. You have to pay the extra. Otherwise, you could just, if you can afford the $270 a month, why not save that for 36 months, have this amount in your savings account, and then you have more than enough to buy the car, and you already had the, you know, you've got the extra, and you'd get to keep that $2,500. All right, love it. Good job, y'all. Let's see. We're gonna go back to this. So here's the monthly payment formula. Ooh, looks awful, right? But if we use Desmos, it won't be too terrible. And notice we already know these three letters. P, that's the amount we're borrowing. So that's the price minus the down payment. R is the annual percentage rate, APR, converted to a decimal, key point. And N is the total number of payments. So N is, you can think about, with cars, you can think about N being the same thing as months. A little bit later, we have to be careful with this N. So we're going to see three different iterations of this formula. Okay, so I'm going to go ahead and add that to our formula sheet right now. And I'm just going to put it right here. M equals P times R divided by 12 because it's 12 months. So we're breaking this R down into the 12 different monthly payments. And then it's 1 minus 1 plus, let me make sure I'm getting this right. Yep. 1 plus R divided by 12 raised to the negative N power. Now, I'm not really going to explain why this works so well, what's going on in the denominator, negative exponents, all that mess. By the way, there are other versions of this monthly payment formula that you can find on the internet. I think you should stick with the one from the book. It'll help you when you're working through your ALEKS problems. So let's do a practice run of this. So we need to know this APR. You're going to find out this isn't exactly the same thing as interest, the quoted interest rate. Lots of times people like to talk about the monthly payments because that's easier to understand and it's easier to make you think you're paying less or more. It's best to think about the APR in terms of, are you getting a good deal? So here we go. Honda is having a President's Day event and they're selling you the CR-V with an APR of 2.9 for 60 months and a sale price of $27.95. We're going to trade an old car that gives us a down payment of $4,500, and we want to calculate the monthly loan payment for this. So I want to know what's the P, in other words, the amount borrowed. I'll tell you, it always shocks me how many students don't understand. You take the price and subtract the cash you pay. This is a common mistake. Folks forget to do this calculation, and a lot of it is I think people are just not thinking about what's going on here. They're just trying to do a formula. what I want, so if you think about it, you're saying, I'm not going to borrow more than I need to buy this car. In fact, banks will not let you borrow more than you need. Sometimes with a house, you can borrow a little extra for like improvements on it. But with cars, nope, you only get to borrow exactly what you need to buy the car. That is not true for student loans, right? You can borrow more than the cost of tuition, more than you owe the school, and you get to use that extra money to live off of. Where was I? I was like at a Meijer checking out, and a kid was talking about how he bought this super nice computer, like this $1,500 computer, gaming computer for college, using his tuition refund. And I was like, oh no, you're going to be paying like 6% interest on that. Oh no. I hope that was useful. I hope that helps you study. I did the same thing, by the way, so I didn't judge it too much.
6% interest is a lot better than what these credit cards will give you. So
Good
anyway,
point.
kind of smart. It's kind of smart, but again, it's really not. But I'm guilty of it too. So.
Well, my parents tell me the story of friends that went to school that had plenty of money, like they had the cash to pay for school, but they took out the loans and bought a car with it because what you said. You know, you get way cheaper interest typically with government student loans than otherwise. Exactly. So you're so right. As long as you know what's going on and you're checking the interest and whatever, and you know you're going to pay it back. Yeah. Okay. So this interest rate, by the way, is amazing. 2.9%. So here's the price of the car. The R is 0.029. The only other thing we need is the total amount of payments, and we're going to make 60. This is a 5-year loan. 60 divided by 12 is 5. So we have everything we need. Just smash it into the formula and away we go. I'm going to write it down, and then I'm going to let Desmos do all the work. So it's this, then all that divided by 1 minus 1 plus 0.029 divided by 12. By the way, the government does allow you to take large loans because they recognize if you're going to school full time, how do you pay rent and food, right? So it's actually expected that you would use that for living expenses, which gaming computers are definitely, I agree, living expense. I'm glad we're all on the same page. Okay, so I am typing in here the 22,795 times 0.029 divided by 12. Now, if you want it to look like the fraction, which I think you should, I'm doing Shift 0 to put parentheses, and Desmos automatically does parentheses around that. You could hit this fraction button, or you can also just hit divide, and then you're into a setup that looks like how I have it written out. So 1 minus parentheses 1 plus 0.029, oops, divided by 12. And then here you got to be careful. I'm doing Shift 6 to get the exponent. You can also use this AB button. And I'm going to type in -60, oops, -60. And there's our answer. We're going to end up paying $400. $408.58 per month for 60 months. Now, if I want the total cost of the installment part, I would just take that and multiply it by 60, and we're paying $24,514.80 for this car. If I subtract from that the amount we borrowed, there's the finance charge, an extra $1,700. Really not too bad. If you know, like, not terrible. How are we doing? Does everyone feel happy? All right. Note, the key to this is, can you identify these pieces and put it together with the formula? That's really, really the main thing that's happening so far in chapter 3. All right. So, ignore all this calculator stuff. Here we go. Author says, hey, what if this loan was based on simple interest? Remember, simple interest is a fixed amount charged over the length of the loan. So you pay the exact same amount of interest the whole time. So we can do a quick calculation of that. It's just This 22,000 times 1 plus this times 5. This is the years. So this is a T. What our author is doing is saying, here's the total cost. The future value would be P times 1 plus RT. That's that simple interest formula. That's where this comes from. I'll smash that into Desmos here. 22,795 times 1 plus 0.029 times 5. That's 26,000. You can see it's already quite a bit more than the here, let me delete this. Quite a bit more than the cost. Almost an extra 2,000, extra 1,500. So 26,100.75. And then if we're going to do this as a quotes installment loan, we would divide this by 60, a fixed installment loan. And this would give us the amount we have to pay each month in order to have paid that total amount off over the 60 years or 60 months. So this is $435. If we compare that to the previous amount we just calculated, that was 408.58. So we're paying an extra $26.42 per 1 month. So why is it that the simple interest costs more? Why do we end up paying more over the lifetime of this loan in simple interest as opposed to the monthly payment formula, which is working on compound interest?
Because as you pay off the loan, the interest that you owe is gonna decrease.
You got it. Nailed it, Jennifer. Yeah. So remember, compound interest is based on the current balance. So each month, as we make a payment, this balance is going down a little bit. If you've ever looked at the amortization schedules, it shows you how much of this goes towards the principal and how much goes towards interest. And at the beginning, it's like all interest. And then eventually the principal, it flips and the principal gets paid down and you get charged less interest over time. So it's a diminishing amount of interest. Whereas if it was a straight simple interest formula, they calculate the fixed monthly charge off of this and it never decreases. That's where that extra comes from.
So not to be nitpicky, but you got 0.75 up here and it needs to be 0.27.
Be nitpicky. Awesome. Thank you.
Thanks.
0.2. Oh, I'm going to be nitpicky now. It's 0.28.
Well, technically, yes, but I was just
Good. Here, there.
All right.
There we go. We'll be exactly right. What's funny is that bank will get that money, right? They'll actually
Every last cent they will make sure they get.
Yes, the bean counters, right? I heard a story a while back of a guy that sued, I think it was AT&T or Verizon, because his bill, they kept rounding it up off of like I think it might have been something like 0.74, and they were rounding that to 0.28. So they were rounding his bill up, even though mathematically they couldn't, and he sued and won. Now, I don't know what he won. I should look for that story, but maybe he won his like $1 over the lifetime of his payments. Okay. So interest rates, that annual percentage rate is really important. It's what it is. It includes the fees in your loan, and they spread them out over the loan. So like if you go get a lease, you buy a car lease, and they're like, hey, why don't you just pay for this? It's only $500, and it like if your seat rips or whatever, we'll fix it. We won't charge you anything, and it's only like $10 a month or whatever. So they take all the extra charges that they're trying to tack on to you and they dump it into the loan, and then what they'll report to you is the monthly cost. Oh, this only adds $5 a month, or whatever. And those things get added into the APR. So the same thing happens with your student loans. There's an interest rate, but then there's origination fees, which is the cost to get the loan started. That gets tacked into the loan. And really you just given less. You know, you borrow 20,000, you get 19,000. They take 1,000 to execute the loan. So that all gets added into the APR, and you get an accurate picture of it. Now, our author says that the calculation of these is pretty crazy. We're going to use this formula to calculate. Well, let's see, what does he do here? So lenders are required by law to disclose an APR. So that's a thing to know the true interest you're being charged. And then the way to calculate it, there's in Excel, there's a way to get the rate using this. But we're not going to worry about that. I'm not really going to ask you to calculate APR. We're going to give you that. We're going to tell you what it is. And instead, we're going to talk about what happens if you pay off a loan early. And the way to do that is there's a couple different calculations. The one we're going to use is called the unearned interest that is done with the rule of 78. This is a simple method. You would need to you would have to ask the company you borrowed from, how do you calculate the unearned interest formula? Like, what do you use for the calculation? Is it the rule of 78 or is it something else? And what we mean here by unearned interest rate is the loan person gets less money. So this is respect to the loan. What do we call that? The loanee, the loaner, because they lose out. They're getting cash from you to let you have a big bulk amount of cash. So if you pay it off early, you save a little bit of the interest. I always think this looks kind of like a cuss word, but whatever. We call the amount of interest you save U. F is that finance charge that we already talked about before. K is how many payments remain, and N is the number of payments we started with. So we're going to go back to this one, question 7. We knew the finance charge was, let me scroll back up there. What was it? $1,852. Where are you, friend? Here we go. $1,852. And that's really all we need here, because the unearned interest U is just equal to the finance charge times the number of remaining payments times the number of remaining payments minus 1 times the total number of payments times the number of payments minus 1. So we take this 1852, we multiply it times, let's see, you're going to find the interest you save if you pay off the loan with 12 payments remaining. Well, that's exactly what K is. K is the number of remaining payments. And then N is the initial amount of months we had to use anyways. You can probably subtract 1 from a number and do that in your head. So feel free to do that. You don't have to write this all out if you don't want to. So, oops, why did I get a new tab? We're going to go here and do 1852 times 12 times 11. You all okay with that? Divided by 48 times 47. Wow. We get that we save $108.36 if we pay this loan off 12 months early. Now, here's the thing to think about. The monthly payment was $231.50, right? So in the month where there's only 12 payments left, we have to cough up $2,778 in order to save $108.36. So you got to think about, is it worth that? Is this, a good amount of money, or is $108 worth saving? A lot of people will say, yeah, it's always worth it to save some money. But then you have $2,778 less in your account. Like, what if your car breaks down and now you have to get some repairs? Are you going to have to toss those repairs on a credit card? And this amount is only 3.9% of the amount you pay. So you're getting a really tiny return on your investment. If you could invest this $2,778 like in the stock market for those 12 months and get, say, a 10% return, you would make more money off of the stock market than the savings you get from paying it off early. So that's the thing you should think about anytime you're working on, anytime you're thinking about, should I pay this loan off early? You want to look at how much money you're actually going to save by paying it off. Typically, credit cards are always worth it because they have such huge amounts.
I have a quick question.
Please.
How come it's -1 when the like equation up top says +1?
Because I'm wrong.
Okay.
That's just it. Okay. There we go. A little bit more money. Okay, so how does that change? How much? What percent does that make this? A little bit higher percentage. Cool. Good question. Get the formula right is what I need to tell myself. All right. So, oh, we did that. So in this situation, you surely want to know how much it would cost to pay off the loan. So we're like, hey, what's the total cost of all the remaining payments after the 36th payment? So we made that 36th payment. There's 12 left. That's this 231.50 times 12. So that's how much remains. Now, really, since we're paying it off early, we get to subtract from this the amount of interest that we aren't going to have to pay, which is 122.84. Why is this? Okay, there we go. So we're going to take the 27.8 minus 122.84, and so the total we would have to pay is that 2655.16. So I already mentioned this. Is it worth it to pay it off early? I don't know. That's going to depend on each one of you. So how about you try this one? See if you can't get the amount of interest saved and the payoff amount if you do this one. So let me give you 5 minutes and I'll turn on the, I'll share it on the whiteboard. I think I have to do this. There you go. Can you all write on there? What did I do? What did I do last time that made it so you could write on the whiteboard? There we go. Okay, now you can do it. I'll go ahead and copy the details for those of you that don't have a book. Fail. Set a timer for 5 minutes. How y'all doing? Are you able to even write on the screen, or is it? Can you even see the whiteboard? Oh, okay, perfect. I like that. I mean, I'm not excited that you're lost, but that's okay. So let's go through this then. So what we're gonna do is find the interest saved, right? Well, this is this formula that I got wrong before. F times K plus 1 all over N times N plus 1. So we need the finance charge. Well, the finance charge is the difference between the price of the thing and the amount we paid. So we always pay more than the price of the vehicle because we borrowed it. So we just have to do the monthly payment times the number of months minus the 16,500. That's going to get the finance charge. Love it. So we're paying an extra $2,550 to buy this truck. From there, we got to figure out, well, what's the K? How many payments are there remaining? So if we pay it off in the 42nd month, or if we're going to do that as the payoff. After we make that 42nd payment, there's 18 payments left, and our N is our 60. So smash these things into our formula and we've got the result. Why am I writing U? So U is equal to the 2,550 times the 18 times 19 all over 60 times 61. This will give us the, where are you, dead ones? The amount we save. Whoops, why am I doing that? 60 times 61. So 238.28. Okay, so this is the interest saved. Thanks, there's our 5 minutes. All right. So then if we want to calculate how much we're going to pay, then that's the 18 months of payments that we still have to make after that 42nd month. And that times there's 317.50. And then we'd subtract from that the interest savings by making that lump sum payment. Nice. Okay, Jennifer, I'd like to see that. That's very common that we overthink stuff, right? We're like, oh, this is great. Although there's a lot of moving parts here that you have to keep track of. So I get this is fairly challenging, so don't feel bad. Like the mathematics isn't too difficult, right? Just a little multiplication and subtraction. But the context is quite a lot. So that's $5,476.72. We need this much cash in order to save $238. In my opinion, probably not worth it because I probably can't do it. Payoff amount. But if you have a car loan and you see that payoff calculator and they're like, hey, this is valid for 15 days. This is how they're doing that calculation. Okay. So, yeah, let's go on to credit cards. Those things are called closed-in credit. Because you got a fixed amount of payments, there's a specific payoff, and there's often like that asset that if you stop making payments, the bank comes and takes the car back. So they still have a chance of recouping money if you default on the loan. Same thing with a house. We call that foreclosure. They just come and take your house and they sell your house and get some of the money back that they loaned. Open-ended credit is where there are no fixed number of payments and a payoff date. And this is just a very common thing is a credit card. And each one of us has a credit score associated with us to determine, based on a bunch of different criteria that companies have come up with, that says, hey, you are able to make this, pay off this much money. So it's related to your income, it's related to how much experience you've shown with credit. There's a bunch of different stuff that goes into that credit score, and it's a funny thing. So one way to do it is the unpaid balance method. This is very uncommon, but it is a way to calculate the finance charge, and that is whatever you haven't paid off at the end of the month, you're charged a % interest of that amount, and that percentage gets tacked on to your balance, and you have to pay that back beginning in the next month. So here we go. Suppose you had an unpaid balance of $356.75 at the beginning of August, made some purchases, made a payment. You've got this interest charge per month, and we're going to find the finance charge and the balance on September 1. So here we're going to find the amount of interest that would be charged on the unpaid balance. Well, this is just straight a question from chapter 1. How do we calculate percent of? So this 1.8% converted to a decimal is this. Now notice it's per month. We've talked about APRs all the time. So if we want to know what is the actual yearly interest rate, the APR on this credit card, it's really this times 12, which is 21.6% APR. They don't charge you 21% every month. It's each month they charge you a 1/12 of that. It gets tacked in and then it's compounded. So by the end of the year, this is how much you will have paid in interest, or that's what the compounds, I mean, that's the percentage rate you're being charged, but the actual amount is growing over time. So it's a pretty dangerous situation. You should always pay your credit cards off to avoid that interest. So here's the finance charge, $6.42. Not a big deal, right? What's $6.42? Next month, you're going to have 1.8% of that plus more. Okay, so now we're just going to run through what we did. So we had, this gets added in. So we have the previous balance, $356.75. We're going to add to that what the bank is charging us, $642 for the privilege of using this credit. Then we did another $436.50 worth of purchases in August, and we made a $200 payment. So add those four together, subtract that, and we get the new unpaid balance for September 1st. So 356.75 plus 6.42 plus 436.50. That's $799.67. That's all the negatives towards us. We're going to subtract from that the 200 that we're paying down, and we get the new unpaid balance is $599.67. So this is the new balance before September 1st. But then they're going to charge us another 1.8% of this that's going to be dumped in into our account. So let's do that. 599.67 times 0.018. And now we get added another $10.79. So September 1st balance ends up being $610.46. If we're not careful, this is going to get out of control, right? And we're going to get into trouble. Okay, unpaid balance method, not very common. Simplest for calculations. Sometimes it's more. It works out to being more. Sometimes it's not. So let's look at the average daily balance method. This is the most common method. It means they start charging you interest the moment you swipe your card, and it begins compounding. That's what our author is saying here. Okay, so this works best in Excel. So I'm going to open up an Excel spreadsheet. And I'm just going to copy this into Excel and show you how to do this. There's a worksheet problem for the 3-3 worksheet that I encourage you to do the same thing. Just run an Excel on it. So what we need is the dates, August 1st, August 7th, August 12th, August 18th, August 24th. We're going to need to know the current balance. And then later we're going to need to know days. So we'll add to this in a little bit. Let me make this font size bigger. So we all can see what's going on. There we go. Okay. So first off, the previous balance beginning on August 1st is $356.75 for this thing. Now, think about what's happening here. We're looking at how much we're thinking of this as the amount of money on the card. So we're going to add to that previous balance a purchase. So on August 7th, we spent $59.95. And then on August 12th, we made another set of purchases. So we take the previous balance and add to it $223.75. Now here's where it gets tricky. On August 18th, we made our payment. So we're going to subtract that 200. So what this balance is the amount of money we owe the bank. So anytime we make a payment, that comes out as a negative. Anytime we make a purchase, that looks like a plus. So these are the balances each day. All right. That's what we were supposed to do here. So what is the balance for each of these days where it changed? Now, then we have to ask ourselves, for how many days was our balance $356.75? So we went from August 1st and then it changed on August 7th. So let me go to August and we can just count it. So 1, 2, 3, 4, 5, 6 days. It was 356. On the 7th day, it switched to 416.70. So 6 days here. Notice that was 7 minus 1. That means for the balance of 416.70, it would be 12 minus 7 or 5 days. And then 18 minus 12 is 6 days. 24 minus 18 is another 6 days. Really? Whoops, I put a 3. And then we get into the tricky one. How many days does it remain 593.25? Well, if we count it, note we start on August 24th. That counts as a day it's this balance. And we're going to count up to the 31st. So 1, 2, 3, 4, 5, 6, 7, 8 days it remains at that balance. September 1st, it switches over. So we can't do August 31st minus the 24th to get the 7 days, because that excludes the 31st day. It doesn't change till after 31. So our strategy of subtracting the days back here doesn't work for the very last date. I hope that makes sense. How's everyone doing so far? Are you kind of getting this? Okay, so next, we're going to multiply the balance times the number of days. That's number 5 here. So we're just going to do, I'll label this balance times days. Oops, wrong one. What? When did that happen? Times days. So that's where Excel is super nice. We just hit equals and we do this times this, and I drag this, and these are all the balance times the days. So what we're then going to do is figure out, well, how many days are there in August? So that's the sum of these. We should know this better come out to be 31, otherwise we did something wrong. And here we're going to add up the balance times the days here. And this is the dollars per day sum, and then we're going to get the average daily balance by dividing these. So we're going to take this value and divide it by this value, and we averaged a 498.56 balance for all of August. That's the daily balance. So then we have to figure out what is going to be the interest charged off of this average daily balance. Well, that's equal to the daily balance times the monthly interest rate. So we're going to be charged $8.97. How are we doing? So the final balance that's going to appear on September 1st is going to be this ending balance, 593.25 plus our finance charge, 897. Now be careful, a lot of students make the mistake of taking the average daily balance and adding the finance charge to that. We should call this finance charge, shouldn't we? But don't do that, because this is the amount we owe them, and then we add the finance charge to the amount we owe. Note that this is a little bit lower cost, $897, than the unpaid balance method back here, which this is essentially the same charges here. Which we were charged $1079. So the average daily balance was a little lower. In this case, it worked out for us to be cheaper. It doesn't always work out that. It would depend on how many days the balance was at a particular amount. Okay, so there is not a nice formula for doing this. Working through this problem, you have to just know this process to get through it. So I really encourage you, you're going to see it on the 3.3 worksheet. Run it in Excel. It makes it so much simpler because there's a lot of tedious calculations here. All right, so the big deal here is how do we get rid of this interest? Like how do we pay off these credit cards? So you probably know, if you have a credit card, that there's always a minimum payment. And it used to be that minimum payment could be whatever the credit card company wanted to set it to be. But then in 2003, I believe it was the Obama administration and Congress and whoever came, I don't know who passed this law. Well, what happened is these minimum payments were getting smaller and smaller, so they didn't even cover the interest being charged. So the amount you owe was just growing over time if all you did was make the minimum payment. The federal government put in some financial regulations that said you can't do that, credit card company. You have to make the minimum repayment enough to at least cover the interest in a small part of the principal, so that if all you're doing is making the down payment, that it decreases. The author notes here that how that happens is determined by the company. It just, they have to pay interest and some principal. And it was, you know, if you're a type of person that hates government intervention, this is one of those cases where the government intervening was actually helpful for people who don't really understand minimum payments and what's happening with credit cards, essentially forcing the credit card company to act in the consumer's behalf, best interest, sort of, right? Okay, so we're going to look at what's happening here. So let's suppose you have a $2,300 balance on a credit card, and it has a monthly interest rate of 1.5%. And then the minimum payment is the amount of interest plus 2% of the principal interest, or $20, whatever's higher. And that's assuming you don't make any more purchases. Let's see, how much will you pay down? All right. So let's see, we know our P is 2,300. The author makes a fun point here. So it sounds like we have to compute some interest if we're told that interest is 1.25 per month. But it doesn't actually matter in this case, because we're not asking how much are we going to pay. We're asking total. We're just asking how much of the account balance will remain. So this is an exponential decay problem where the amount that remains is going to be 98% of the principal each month, right? So we have 100% of the principal minus 2% equals 98%. So this is an exponential decay problem where this is the percent of the balance that remains. And if you recall, that thing was the decay factor, which was B. The principal here is the A, the initial value. And we've got a nice little formula now to calculate. We got 2,300 times 0.98 to the X power, where X is going to be in months this time instead of years, because we're paying this amount per month, that 2%. So we can see how much remains in the account after 6 months simply by putting a 6 in here. Now, you already may recall that I love function notation. So if I did this, I could just do f of 6, and this would be the remaining balance. So let's scamper over to Desmos and do that. Let's get a new graph. So I'm going to do f of x, and that's equal to 23. Oh, okay, that's equal to 2300 times 0.98 raised to the x power, and I want to know how much of the balance remains after 6 months. Oh, $2,037.44. $2,037.44. So what that means is we have made 6 payments, and after those 6 monthly payments, all that we've paid off is $262. Now, how much did we pay? Well, if you think about the percent we're having to pay each month, maybe we don't want to try to calculate that. Yeah, let's not worry about that, because that's going to be a little bit complicated. We're going to have to do a bunch of calculations. So here it says, well, find the new balance after the first month. Well, let's do that. So f of 1, the new balance is 2254. Right? So if we look at how much did we actually pay on the principal after the first month, that's the difference between those two. That's $46. What we could do then is think about how much did we actually pay. We paid $2,300 times 0.0325, right? Because we had the 1.5% interest that we're paying, plus the 2% on the principal. So the total payment we made that month is $74.75. So we had to pay this much to bring our balance down $46. In that out, go 6 months out, and we've now only paid down 2,000. We've only got our interest down to this, right? Again, remember, we have to not use our, we can't use this credit card anymore to make it do this. If we're adding to that balance, then we're not paying anything down if we're purchasing. So the real question here then is, how long is it going to take to get this? How long is it going to take if we just pay the minimum balance to get this thing to $10? So we'll say, how long until the balance is $10? So if we think back to what we did in unit 2, we took our function, we typed in y equals 10 in Desmos, and then we looked for where the 2 intersected. So let's do that. We'll solve that. Here's the 10. Now I got to zoom way out. In fact, I know my starting value is 2300, so I'm going to go here and change my y to go from 0 to 2300. And x is in month. Let's go 0 to like 200 and just see if it shows up. It did. Maybe that was a little too much. You can see that. There we go. Ooh, it's going to take us 269 months to get us to $10. So just 22 little years. So this is why this is kind of it's awful if you think about that. If you're just making the minimum payments, you're going to be paying that minimum payment for 22 years just to get it down to $10. Now, at some point, right, you're like, oh, what if we just say, let's get it down to $100? How many less years is that? Because once we get to 100, we might be able to just do it. Well, that's 155. That's still 12 years. And remember that the credit card company is making money off of each one of these payments, because a good portion of this is interest. Although once we get down here, this is more principal that you're paying than interest. Okay, that's that. So here's where I want to see if that made any sense to you. In the course pack, we're looking at the 3.3 worksheet. I've got a picture of a car that you're purchasing. I'm giving you an APR amount. Notice I'm giving you a down payment amount, and you're going to run through and calculate these things using the unearned interest rate, the rule of 78, and all that. So practice what we just did. Here is the credit card problem we just did. So I've got a balance and then some payments and subtractions. One thing to note here, the way the dates are written on this is like a European way. So it is day first. I've got it listed here. The day first, then the month, then the year. Notice that December 1, it's this balance, and then it changes when you make your $250 payment. So run through that. I encourage you to use Excel to do that, to practice that. So y'all think you can do that? Do you want to take a few minutes and try it out, and then we check your answers? I mean, let's do that, unless you're all sick of this and ready to go. Okay, yeah, let's do that. So let me give you 5 minutes to work on A and the front page, and I'll see where you're at. Maybe I'll extend the time if you need it. Set a timer for 5 minutes. Sorry. How y'all doing on 1A? Anyone got an answer? Or do y'all need more time? Tell you what, you all let me know when, oh, here we go. Ooh, 6:30. Let's see if I agree. So the P is 34,590 minus 2,000. R 0.06 in 60. So we're going to do 32,590 times 0.06 divided by 12 divided by 1 minus 1 plus 0.06 divided by 12, all raised to the negative 60. By the way, easy mistake to make. I've done it multiple times myself, is to forget to put this negative in. The good news is it'll be quite obvious, I think, in Desmos, wrong one, if that happens. I'll do it here so you can see what it looks like. Oops. Oops. Like you get a negative number, right? So that should be clearly a clear sign that like, oops, I messed something up because they're owing me money. Put in the negative 60, there you go. Nailed it, Jennifer, great job, 630.06. Oh, we can't forget to do the lesson check. I just closed that. I'm pretty upset about that. Okay, so that's going to be our monthly payment. Did you all have time to do B? Okay, let me give you, I'll give myself 5 minutes to stop talking. Set a timer for 5 minutes. While you all are working on that, I'm going to figure out what the lesson check is. How we doing, y'all? That was the 5-minute mark. Y'all ready to talk about B?
I'm almost there, but I'm not there yet.
Okay, well, take your time. Let me give you more time. Set a timer for 5 minutes.
I think I'm done, but I don't know. My number seems low.
You're probably right. In terms of the number is always quite small. Okay, so did you find the finance charge? That's the first complicated thing you have to do. A total interest. Yeah, that does seem really small. You might be right.
Finance charge I got was $5,213.60, but I don't know if I did that right either, so.
Okay, let me erase and you tell me if this is how you calculated it. So what you would do is take the total amount you paid over the lifetime of the loan times the monthly payments and subtract from it what you borrowed. The formula, by the way, in the textbook we used here was the price minus the total installment price. So you did this times 60 plus the down payment, but so we added the down payment here and we added the down payment there, but this is just a faster way. Is this what you did, Jennifer?
I made it a little more complicated than that, but yeah, that's what I did.
You got it right. Good. That's all that matters. It's okay.
I
if it was
did
a-
630.06 times by 60 plus 2,000 and then like minus amount.
Yeah, that's totally fine. I mean, that's what the textbook does. They do
Okay.
that plus 2,000 minus this number, and it's the same thing. Oops. Okay. So that's the finance charge. And then that's really all we need to calculate the unearned interest, because everything else, well, let's see. No, we need to know the N and the 30th. So you're lucky you win the lottery 29 months into your 60-month loan, and you decide to pay off your loan early. This is a distractor. Ignore that. If you pay the loan in full on the 30th month. So if we pay it on the 30th month, see, N is 60. There are 30 more payments remaining after that one, right? Or is there 29? Nope, there's 30. So we are taking the $5,213.90 and we're kind of spreading it out over those remaining months. So this is 30, this is 31, this is 60, this is 61. Is that what you did? I'm guessing that's what you did. No.
Yeah, that looks like what I did.
Nice. Okay, so I get a bigger number than what you said you
Nope,
got.
I left out the 30. I just, yep, I left out the 30.
No worries. That's okay. You had the right formula, just one tiny mistake. 1324.77. Yeah, it's good that you instinctively knew that $44 was a little bit too low. Especially because we're paying this loan off halfway through the length of it. So we're taking, I mean, if you look at how much of the interest we're saving, it's not half, even though we're paying it half as early. Okay, so then the payoff amount, you would take this 630.06, you'd multiply that by 30, and then you subtract from it the 1324. So if you had the $44, you would be a little bit off on that. Let's see, so 630.06 times 30 minus this 1324.77. You need $17,577.03 to pay it off early. I wouldn't be able to do it, but that's because I'm not very good with money, even though I've got all this math knowledge, right? That's the hard thing with money. It's a very simple principle, but it's the psychology of following through with it. All right, how do y'all feel about this? Good, good. I don't know that we're gonna have time to do this problem. We got like, is the class over? No, that's my in-person class that ends at 50. Do you want to take 5 minutes on this and then we talk about what you did, or should we talk about this at the beginning of class on Wednesday? I'll let you all decide. I encourage you to use Excel either way you do it. Sounds good. All right, then, unless you have questions,